Hello, everybody. It's Keith from Last Call. And today I want to chat with you guys about making worlds for logic games. And so I've titled this, What in the World Are Worlds? In case you don't even know what that term means. We can start really basic and get into what are they, when should you use them, and how should you go about learning them. All right, so a couple definitions up front. I think there are essentially three different ways to approach logic games. And I used to favor one over the other two. And what I've come to learn is that really all of them are interrelated, and that the best approach would be to know all three ways and then to implement the correct one at the correct time. Okay, so brute force. What I mean by brute force is that you're finding complete solutions to test and answer choice. Can this be true? You write out a solution, plug it in, and see if you can find an accurate solution where it's true. That's brute forcing the questions, looking at each individual answer and trying it out by filling in a complete solution that includes that particular answer choice. An alternative to brute force is deduction. Deduction refers to identifying or spotting the implicit rules of the game, the requirements or the restrictions that are created by the rules, but are buried underneath them, not directly stated. Deductions can be really tricky. And what I find in the literature is that most systems, most explanations sort of rely on the idea of a deduction. You start with the deep deduction up front, and then that helps you find the answer to the question. But I'm a bigger fan of brute forcing. I think brute forcing is a more direct path, even on must be true, must be false questions where you have to disprove four of the answers. I think it's more reliable and more direct than finding deductions, unless you're really good at deductions or unless you've already found the correct one. The third approach is worlds. Worlds is similar to brute force insofar as we're looking at individual solutions, but it's different because we're not using complete solutions, or not necessarily. Instead, when we make worlds, we're trying to take the entire set of solutions and split it into a reasonable number of chunks. We might take the solutions and split them in half, or split them into thirds, or maybe into fourths, so that we take a complicated game and we make it half as complicated or one third as complicated. And what's different about brute force than worlds is that when you're brute forcing, you're just coming up with individual solutions. Whereas with worlds, you're trying to represent the entire game, every solution, with a few templates, partial solutions that encompass all of the possibilities for that game. So I don't really like the name worlds. I don't think that it describes the scenario well. I used to call that splitting the board. You have a set of global deductions, and you can split that board or that set of global deductions into two partial solutions that mostly what we're looking for is a fork in the road. I'll talk about that a little more in a minute. But the thing I've learned about these three methods is that they all feed into one another. Brute force makes it easier to find deep deductions. Ultimately, it's sort of the only way to prove the deep deduction. If you tell me, prove to me that S has to be first here, no matter how obvious the deduction seems to somebody, the only way to truly prove it is to have a complete list of all the solutions and say, look, it's always the case. So being able to brute force all the way to a complete solution is ultimately what proves or helps you find or justify deductions that you want to make. Furthermore, being able to find the deep deduction helps you to create worlds, because once you set up the templates, identifying the implications of those templates, finding the deductions from there, allows you to fill in the worlds and make them more usable. And then finally, making the worlds, filling in each piece of the puzzle, that's an exercise in brute force. You're trying to complete solutions to the best of your ability. And so making the worlds ultimately helps you to become better at brute forcing answers. So I find it to be very interesting that these methods are not exclusive. They are complementary to one another. And a good test taker is going to know all three and know when to employ each one. So the question isn't, should I use worlds? Should I brute force? Should I make deductions? The question is, when should I do each of those three things? So let's talk about worlds a little more. Worlds are not just random solutions. Sometimes people call them hypotheticals. To me, that suggests that it's somewhat impromptu. It's not complete. It's just, the ones that you think of in the spur of the moment. Worlds is more global. You're trying to capture all the solutions. And so, what I look for so that I can slice the pie really cleanly are rules or deductions that have one or two options, binary or ternary rules or deductions, because that allows me to make the cleanest slice, either cut the game in half or cut it into thirds. So once you find a binary or a ternary rule, you can then split the board, make the worlds. In other words, for a binary rule or deduction, you split the board into two worlds. And in the first world, we get the first version of the binary rule. And in the second world, we get the second version. And if you combine the two worlds, we have all of the possibilities for the game. Same thing for a ternary rule. If we have three choices for the rule or for that deduction, we split the board into three rows or three worlds and place that particular variable or that particular deduction into all three of the spots. And then we have, if we add the three worlds together, we have a summary of the entire game. There's another way to make worlds that I think is pretty clever. And Mina Perron is a tutor who I really respect from the LSAT group. And she calls this making a double dual matrix. You can make a double dual matrix when you have two binary rules or deductions. And in that case, what you do is you use both of them to create four worlds. So for example, if we had rule 1 was limited to options A or B, and rule 2 was limited to options X or Y, then we would create four worlds and match those together in each of the ways possible in a different world. So A would be matched with X in one world, but then in another world, we would match the A version of rule 1 with the Y version of rule 2. At that point, we would have A matched with both versions of rule 2. So we move to the second version of rule 1. B has to match with X, has to match with Y. So we end up with four different scenarios. And if we combine them all together, they represent all of the options for rules 1 and 2. Once we have those four scenarios written out, we can go and apply the rest of the rules to those four scenarios. But what's even more important is rules 1 and 2 become irrelevant. We don't have to continue applying them. They are implicit. They are baked into the four worlds that we designed. So when I'm looking for rules to make worlds, I'm looking for big blocks or variables with heavy restrictions. And that's not just for the double dual matrix. I should have moved that bullet point to the left one. That's for all worlds, whether I'm splitting the board into 2, into 3, into 4. There's some games where I've done it even into 5 worlds, although I really try to limit the number of worlds that I make. But one of the things that I'm looking for is that I don't want my world, I don't want the rules that I choose to be non-consequential. I want for those rules to overlap with other rules. So big blocks of rules that drive additional deductions, those are good candidates for worlds. In fact, I would say this bullet point is more appropriate for the first version of splitting the board than the second. If I'm only going to split the board once or twice, into 2 or 3 scenarios, I really want the blocks to drive the show. If I'm going to do the double dual matrix, because we're dealing with two different rules and combining them in these precise ways, I find that it almost always does drive deductions. And so we don't have to be as careful about choosing which rules. It's the double nature of the rules that accomplishes the amount of restrictions that we're looking for. So when I'm looking for those big blocks, or if I find those big blocks or heavily restricted variables, those are good ways to create the binary or the ternary set of worlds. All right, next slide. I stole this one from Jake. I don't use worlds very often in time testing. For me, it's an exercise in conceptual development, and I use it during blind review. So I don't worry about when to make worlds. I'm going to make them during blind review, always, because I find it fun. It's an interesting way to take the game apart. But I'm almost never going to do it on a time test. There are a couple exceptions to that, and I'll get to that at the end of this slide. So, first of all, the number of rules, just literally counting them, can influence whether worlds is a good idea or not. If there's only a few rules, it's practical to apply them over and over for every single question. No need for worlds, in other words, on a time test. But there's some games with 5 or 6 rules. In that case, applying them to every single question takes longer because you have an extra 1 or 2 rules to apply, not just once, probably not even just once per question, but possibly once for every answer choice that you're checking in a brute force analysis. So having extra rules adds up as you apply them over and over and over again. The upshot of that is that if you could do the process once at the beginning and then not have to repeat the process of applying 5 or 6 rules over and over and over again, that could have some efficiency dividends. So if I have a very large number of rules, then I'm more inclined to look for one driving rule in particular, or what's more likely to be the case if there's that many rules. Maybe I can find 2 binary rules and lay out the double dual matrix easily. The other aspect that I think about, and this one's actually more important to me than the number of rules, is the level of abstraction of the rules. Are they concrete and easy to symbolize? If so, if my symbols are highly visual, I can just apply the rules over and over again. But when the rules are abstract, when I couldn't think of a good picture for them, that's when they're going to be difficult to apply, or maybe even difficult to remember to apply. So when the rules are abstract, that's when I would prefer to lay them out at the beginning, all the different options, and have a visual tool to help me navigate that abstraction. The kinds of rules that I find to be abstract, they're not even rules so much. They're either deductions or sometimes they're buried in the stimulus of the game. But when the variables can repeat, the frequency of the repetitions I find to be an abstraction, unless they've given it to you. Like they all go in twice. Okay, well, then I'll just write all the variables twice. But when I'm not sure how many times they go in and I have to go about counting them, that's a level of abstraction that I would prefer to sort out at the beginning. Is there a limited number of ways that these can repeat? And if so, can I draw them all out quickly at the beginning? The other type of abstract piece of information is the distribution. This mostly applies to grouping games, but it can apply to order games where you have more than one thing in each spot in the order. If you can have more than one thing in a box, then the question becomes how many things go in the box. Again, it's a counting issue, not a placement issue. And so I find those counting issues to be a level of abstraction removed from my diagram. I can't just look at it and say, yes, there are enough things there. I have to count them. So what I would prefer to do when the distribution is uncertain is pause at the beginning, identify all of the possible distributions, and then represent them each individually so that I can map out all of my solutions onto that framework. So when I make worlds, I tend to do it in a very general way. I make 2 or 3 worlds and they are extremely open-ended. I don't take it all the way down to the individual solution level. But on blind review, I do. I continue to split the board, split the board, split the board until I literally have individual solutions and then go back and count them. That's part of my exercise of blind review is I don't think I fully understand the game until I can tell you how many solutions there are to the game. And usually the only way I know for sure is to write them all out. And even then, I'm not always sure. Made a mistake this week in my prep for class. I finally landed on 32 as the number of solutions for the game. And the only way that we were able to determine that I was wrong is Jake pointed out that two of the complete solutions that I had created to justify this 32 number, two of them had violations of a rule. And so once we eliminated those two from the mix, I was back down to 30 solutions for the game. At that point, once we had consensus, he and I we had arrived at the same number, then we believed that we understood the game in more detail. All right, a couple more definitions just to make sure that you guys are following me. The frequency and distribution are things that I don't talk about often. Yesterday, when I talked about making deductions, I ignored these altogether because I said that it was uncommon to have to make frequency deductions. Distribution deductions are a little more common, but still you don't need them for order games. So this is sort of a fancy higher level type of deduction. So just to reiterate, when I talk about frequency, I'm talking about the number of times that variables repeat. And when I talk about distribution, I'm talking about the number of variables that go in a group or in a box. So the way to tease out these deductions is at the start of the game, before you start fiddling with the rules and before you start making deductions, you should stop and think about how is this set of elements going to map out onto that diagram. And I do a lot of counting. If I have 5 elements and 9 spots, I know I'm going to need some repetitions, but I want to be really particular about that. 9 spots would mean that 4 of the variables repeat and then one of them doesn't, provided that 2's the max, of course. There's some games like that where everyone goes in twice except for one. They don't say this outright. The rules back you into that corner. And it's really important to keep track of the one that doesn't repeat. There are other games where most of the variables go in once, but then one or two of them repeat 2 or 3 times. And in those games, it's the opposite. It's really helpful to track the ones that repeat and how many times they repeat. But you can't do that on the back end, or rather, it's harder to do that on the back end. I prefer to take note of these frequency distributions very early on. Also, when I'm mapping the variables out, oftentimes I have more variables than boxes. And so it becomes obvious to me that I'm going to have to start grouping them together. And in that case, I start thinking about minimum numbers and maximum numbers. Do I have to put anything in the box at all? Can it be empty? If it can't be empty, is there a minimum number? Is it specified in the stimulus? Sometimes they specify a maximum number rather than a minimum. Sometimes they tell you the exact number. But there are other times where they don't specify the maximum, but you can figure it out. You can figure out that if we have to have at least 2 per group, and then I have 3 left over, that means that the most I could add, on top of the 2 would be 3 more. And so they all have a max of 5. Sometimes you can come about those deductions, the distribution deductions, in a roundabout way, but it all entails taking 15 or 20 seconds to investigate or imagine how the variables map out onto the diagram. So that's a follow-up from my discussion yesterday on how to make deductions. And I'm going to stop the recording there and take some questions. Give me a second to get this right.